Cameron, so good to be visiting with you again, my friend. If anybody isn't aware, you have a one of the best podcasts by far as anything with health and understanding quantum biology. Your desire to understand and learn and make it easier to understand is, dude, so admirable. I have benefited greatly from the content that you put out and the people that you have done. So, man, just first off, before we get in, just thank you for what you're doing and sharing it with the world.
I really appreciate the kind words. It means a lot to me. So yeah, just glad to be able to share this stuff for free. Yeah, it's a real passion project.
I love it, brother. I love it. Last time you were on, we went into how you were viewing cancer and some other aspects that were a layer that were incredible, right? Like it is something that nobody's really talking about. So if you will, let's go into some of the guests you've had, how you've been able to package some of this knowledge to have such a unique perspective. And I think that this is going to be the groundbreaking thing that we are able to break through and have just massive impact. So go into some of the guests that have just kind of helped package this perception that you have as how you look at biology.
Well, I mean, from a recent point of view, speaking to Alastair Nunn, who is one of the lead scientists at the Guy Foundation, and I think pretty much everyone at the Guy Foundation, for anyone who doesn't know, Jeffrey Guy made quite a bit of money researching the effects of cannabidiol and basically sold his company for a large sum and
Very.
has basically reinvested a lot of that back into research that he would like to see funded. Real philanthropy in a way that I think so many people are benefiting because the people who are doing such phenomenal work in science, they're getting grants now to do work that they wouldn't otherwise be able to do. And they have much more freedom to ask questions that they deem to be, going to be very fruitful at some point. And Alastair is a big part of that. He's a theoretician, which is, a pretty awesome job to have because you get to just think about how things work. And he is surrounded by a bunch of people that are studying very intently in a variety of different topics. So he can just reach out to all the best people in the area and understand their points of view and they can put it together. And the Guy Foundation have all of these roundtable discussions basically with all of their researchers, which is great because you get to put so many different, you get to put physicists and you get to put biologists and you get to put electrobiologists all in the same room and say, talk, figure it out. And Alastair has, basically absorbed all of this knowledge and he could talk for hours. It was quite remarkable. I think we did like 2-ish hours and we could have easily gone for more. And, he has a lot of interesting ideas, particularly surrounding things like, what inflammation is, and what is cancer, like we were talking about before. And why are biophotons emitted from every living cell? Is that sort of a way to define life in a way? And yeah, I mean he has really shaped. There's a few papers of his, one talking about plant hormetic compounds. So basically these compounds in plant foods that if you look at them in a vacuum, if you extract them and use them on like a cell in a petri dish, they're toxic. They appear to be toxic. But in the context of the whole food, they elicit a hormetic response. His work in that area has really helped me understand the role of food in communicating information and basically being able to interact with light. A lot of these plant hormetic compounds, everything from quercetin to resveratrol to even NAD, the energy carriers in the mitochondria, they all interact with light very, very strongly, typically in the UV range, which is very interesting. And, it just makes you think about what these plant hormetic compounds are there to convey to the body when you consume them. And I think this is something people who, they talk about plant foods as if they're toxic, and you read a bit more into this work and you realize, yeah, that's the point. This hormesis style response is directly related to fitness, and I think where it's sort of lost in the fray, and where Alastair needs to go from here, from my perspective, is integrating that into a way of thinking that goes back to traditional populations and eating foods within their natural context that we don't particularly do anymore. And I think I asked him, I can't remember in the podcast, but I was asking him about, what happens if you eat, a tomato grown in Spain, if you eat that in Siberia, what sort of response is that going to elicit? Could it be a negative response? And I suspect in the same way it might yield a negative response, you could also use something like that medicinally. And I think that's sort of where we get this distinction between medicine and food, is the way in which the compounds respond in the body based on everything else that's going on in the environment. So Alastair has been very influential. His papers with Jeffrey Guy and Jimmy Bell on plant compounds and inflammation, they have one on hormesis to try and explain the Fermi paradox, which is very interesting. So that was very influential to me, and is as well, because they're still publishing, and everything that's coming out of the Guy Foundation is really interesting. And you probably listened to the podcast. He mentions this idea of multicellular organisms are basically a conglomerate of cells that are capable of also living independently. And he said there's this idea going around that the breaking off of a cancer cell trying to do its own thing may have been an evolutionary advantage. If you have a cluster of unicellular organisms and they find that they can function better together, and they all come together, and then if the environment changes, which it does all the time, and it kills all of them because they're all sticking together in the same spot, then everything's gone. But if one cell breaks away and says, you know what, I'm going to make it on my own, and I'm going to find a new niche, and I'm going to come up with different ways of adapting, then if the environmental shift kills all of the other ones, but this one cell that broke away found a new niche where it's not affected by this environmental shift, then that might explain, or maybe a hypothesis as to why cancer might even be an evolutionary, or may have at one point been that style of metabolism and breaking away might have been an evolutionary advantage. Now, I haven't read any literature suggesting that, but he brought it up as if it's a hypothesis that's been out there, and one that's been discussed. And I think it's a really interesting way to think about it, because at the end of the day, I think cancer really has to be thought of in the context of the fact that we are a conglomerate of cells that somehow cooperate with one another. And because we are made up of bacterial components as well, and that symbiosis can break down, it's not beyond the realm of possibility that this style of metabolism, where one cell wants to break away in case something takes out the rest of the colony, so it might be able to survive. I think these are logical questions to be asking with regard to cancer. So that's just a little bit.
Really, really interesting, because we've basically been on the metastatic aspect of trying to differentiate between what a tumor is and then metastasis. And so one thing that I've actually found is that, and Petra and I have been talking about this all day today, is that we have some sort of an immune-like function, right? The cancer cells are actually operating almost like a macrophage, a neutrophil, like they're having some sort of a immune-like reaction, and it may be exactly what you're saying with what Alastair said, but what I'm finding really interesting is that this happens almost in line with the order and chaos, right? Like Turing's ideas on mathematical formulations, and so Cameron, I've even found some support for mitochondria are being transported by the immune cells. And it's just really interesting to see that maybe we have some sort of a electromagnetic component that is going into all those different facets, right? And you talked about the Guy Foundation bringing all of these different disciplines in together. That is the exact opposite of what we've had, right? Like we've been hyper siloed and not having this crosstalk. And I think this is why I get so excited about your podcast. You have a biologist and astrophysicist on at the same time, and I think that's so important. So go into a little bit about what you know with Levin's work and how the communication with metastasis could potentially align with what Alastair's saying.
It's a tough thing to try and get a grasp on, because I don't think even guys like Mike Levine have it fully, like I don't think there's a good grasp on it in that sense. But what we do know is that there are specific electrical signals in cancerous growth, and notably, Levine's done work with Brooke Cherenay on the bioelectrical signals in cancerous cells. And there's a few papers, if you look them up, they've done a few papers together. And I really like Mike, because he writes in such an eloquent way where you can see he's definitely saying certain things about the current regime are completely backwards, but he does it in such a beautiful way as that you wouldn't suspect it reading like the title or the abstract. But what they're definitely saying is that the signatures of cancer, beyond Warburg metabolism, which seems to be more like an effect, not a cause. It just seems to be something that happens in response to cancerous type growth. But what is a predictive factor is a loss of bioelectricity in the cell. And if you can rectify that, which they have done in, I believe, a few models now, if you can rectify that bioelectrical signal, the growth and metastases does not occur. You do not get tumors. And this is, this is sort of born out of the fact that they work a lot with planaria. And, we have this idea that cancer is genetic mutations. It's the genetic material gone wrong. But planaria they have one of the most messed up genomes. They're mixoploid. Their genomes are like all over the place. They're not ordered at all. But planaria are really good at basically adapting. There's a great podcast that everyone should listen to. I don't know this guy, but he managed to get Nick Lane and Mike Levine on the same podcast, and they spoke for about 2.5 hours, and it's fantastic. I think it's only got like 40,000 views on YouTube. No one knows about it. I don't know how this guy organized it, but bless him, because it's a fantastic podcast, and they discuss how planaria organize their genome in a way to make sure that they don't have runaway growth, because they're extremely good regenerative capacity. And, there's a very, very thin line between regeneration and cancer. Very, very thin line. This is why Becker grew to dislike Bassett so much, because Bassett just started making devices that would help bone regenerate. And Becker was saying, how do you know it's not going to tilt the wrong way and cause cancerous growth? And of course, you don't have to worry about that. FDA approvals are quite easy to get around. If you can just prove that it would regenerate bone, then you don't worry about the consequences, basically. And that's a tricky thing to navigate. And planaria are such a perfect model, because they're like immune to cancer, even though their genomes are completely messed up, which is sort of against the common idea that we hold now, which is that cancer is a result of genetic problems. But you can have damage to your genetic code and not develop cancer. I think even back in 2006 when Nick Lane wrote Power, Sex and Suicide, the best predictions then were you needed at least 8 to 10 mutations in the right place in the genome to trigger a cancerous growth. So it's not just you get one mutation and you're done. You need sort of a few of them in the right places to trigger that. And it seems that bioelectricity is more of an important factor than the genome itself, and we know that from planaria, because if you look at their genomes, you would say, wow, this is going to cause malignant growth for sure. But it doesn't seem to be genetics that's the linchpin here. It seems that the bioelectrics are much more important. And then you might want to ask.
Well, I think that's such an important point because it ties in a couple other things. So, like, one is the whole deuterium story. I think that's a massive part of what this is. But something that I don't see talked about enough, in my opinion, is the epithelial glycocalyx. This is the electromagnetic connector. It's the interface between all tissues, right? All cells, everything. So when that gets messed up, whether it's deuterium, whether it's EMFs, it's lack of sulfur, like whatever the issue is, that's what throws off that bioelectric charge. We believe, right? Like this is at the core of what we're saying, that we have a nanobubble aspect of this, the deuterium overload. Like there's so many things. That's what also makes this. It's very complex and it's not a linear singular thing, right? Like it's a lot. So do you care to go into whatever on Glycocalyx? A lot of this work, Hans Fink and Barry Ninham, it's absolutely, and that's a country mate of yours, is Dr. Nunn. So what do you know there, and then anything you want to tie into what you're saying about it's fascinating. I love it. Just tie it all together if you can. Tie this together, brother.
I must admit, I know Barry Ninham, I know his work, but I haven't delved into it all that much. I know he's not a fan at all of Jerry Pollack and the people in that crowd, like Emilio Del Guidice, talking about what the water is doing, all of these different structural components of water. I know he's not a fan of that, and I haven't had contact with him, so I don't know what he's like, but I don't think he's the most forthcoming person or the easiest person to understand. So I must admit my knowledge on that is limited. But certainly it is the case that deuterium content is a very, very important factor in the growth of cells in general. And we know this from, using different amounts of deuterium to see how it affects plant growth. There seems to be this Goldilocks zone. You can't have none because the plants just won't grow. But if you have too much, it also impacts plant growth. I think this Goldilocks zone is what defines the Goldilocks zone is a function of all of the other things that are going on in the environment. And this is one of the things I asked Jack Kruse at one point, which was, is an elevated or relatively higher deuterium level at the equator, where you've got lots of ultraviolet light, where you've got different amounts of magnetic field strength, is a higher level of deuterium relative to elsewhere, is that going to be beneficial to have? And he said, and I think this is logical to say that if you're somewhere where you're surrounded by coconuts and mangoes, then that's probably somewhere where nature's telling you a higher amount of deuterium relative to hydrogen is going to be beneficial. And I'm not sure, I will find out soon how much Gabor has looked into perhaps the quantum effects, the kinetic effects of deuterium versus hydrogen, and how that might be affecting energy flow. But I think getting deuterium into the mitochondria is enough to impact energy flow. And when you impact energy flow, you increase the resistance to energy flux in general. And when that resistance gets too high, that's when you get sort of cancerous growth. You get all sorts of diseases. Everything comes back to mitochondria because if there's too much resistance, i.e., not enough energy potential or not enough energy flow, that's when things go horribly wrong. It's like burning a candle really, really fast. You get down to the bottom very quickly if that flow isn't very controlled and in the right place. I wish I could add more to this whole nanobubble story. I'm aware that the Glycocalyx, and I think Stephanie Seneff is looking into this quite deeply as well, with regard to the enzymes that exist inside the epithelium, like nitric oxide synthases and all of these nanobubbles, which are most likely changing the composition of water. But to come back to Levin, and I don't know if you saw, there was a big Twitter conversation between him and Alexis Cowan, and he makes it very
funny
clear.
Story on that. Like, that happened right before Jack. I interviewed Jack. So, like, this last one that we just put out, he was all fired up and mad about that, and so I got to let's just say benefit from him being aggravated. How about that? But yeah, go ahead, buddy.
Oh no, it's funny because I had been trying to organize a podcast with Mike, the few days leading up to that, and then that happened. And I have an enormous amount of respect for Mike. If anyone wants to learn, just go to his YouTube channel, and the conversations that he puts up for free, I feel like I should be paying so much for. But he makes it clear that when it comes to bioelectric signals, EMFs are actually a really bad way to modulate the bioelectric signal, and he's looked at it very, very closely. I think with these guys, what I've come to understand about these guys is they know a lot more than they let on, and they've experimented a lot, and they know things that have never been published and they've never really spoken about. So I hope he's right in the fact that the bioelectrics are not that impacted by man-made electromagnetic fields, but I suspect other things are going on with the fields that might be perhaps indirectly modulating the bioelectricity, but that has not been shown enough. I don't think there's been enough research in that area, but from what he's done, and it sounds like he's done a fair amount, and he was saying he's had grants to research it. Like, there's people interested in it, and I think that there's quite a large underground that we're just not aware of sometimes. It was like that going to the water conference. You go into this room of people who have been studying water structure and fluid dynamics for 30, 40 years that you've never heard of. And they've been doing this stuff just like Jerry, just as groundbreaking as Jerry. And I'd never heard of them. But they're out there. Yeah.
Well, that goes back to what we were talking about before we got started too, the exposure, right? That's why podcasts and some of these other newer mediums are so important. That's why we have scientists wanting to get onto our podcast because their paper's not going to get read by anybody. And it's a published paper. This is what always the argument is: show me the science. But Cameron, I'll go back just a little bit to even Jerry, right? And I'm sure you've seen this. We've done, between us, I bet we're pushing 300 interviews of world-renowned experts, right? Everybody has blind spots, right? Absolutely everybody. And one thing that has been clear to me is that when we hit these blind spots, ego sets in, and we get some pretty nasty feelings towards each other, right? But if we could do what the Guy Foundation does, and it's about the collaboration instead of any ego and attacking. But if you look at what Dr. Kruse and then Barry have done, like the way they poke holes in a lot of what Jerry's done is pretty eye-opening. I don't know how you could argue with that. But they also have some areas to where they're not willing to. I think Jack by far has the most complete picture of anybody I've ever talked to. It's mind-blowing on that context. But with like Dr. Pollack, we have what would happen if it was deuterium depleted water? What happened if we're studying UV versus infrared? If we're taking into account the glycocalyx and nanobubbles, how would that affect the water? Like what Barry is brilliant, and this is an area that is so small in the conversation that it gets overlooked by everybody else, but I think it's as important, if not possibly more so, than some of the other stuff we talk about. So that's why what we're doing in the continually improving and trying to understand it and not having ego, that doesn't mean I think anything less of Jerry Pollock, because I think that Barry has a point that he doesn't, right? That this is what it is. Barry doesn't talk about melanin, and we know how important that is, right? So when you bring it all together, I think that's the magic, and that's why I respect and appreciate what like you and Max Goldhain and what we're trying to do is so important. So you got anything to add to that?
I mean, I think, like I said before, the more I've come to know these guys and look at their work and hear them speak, is that I think a lot of them, if not all of them, know a hell of a lot more than they let on. I think they're consummate professionals. They are careful not to talk out of term. And, in some sense, I'm surprised how much Jerry's willing to speculate. And I really respect that because... particularly when you're on a podcast, the evidence of that conversation is going to be around forever. So if you're speculating, you want to be in a place where you feel like you're quite confident in your speculation. And some people just won't speculate. And I think at the end of the day, and I've felt this with Jack as well, speaking to him, is that I think these guys, they just know a lot more than they let on. And I think that that Twitter conversation with Alexis and Mike sort of let everyone know that Mike knows about all this stuff. He's not burying his head in the sand going, I'm not going to think about EMFs, or I'm not going to think about that. He knows. He's not dumb. All of these guys in the field, they get it. But they have to focus their efforts somewhere because they have to actually do research. And I think what's great about Jack is that he's not doing research. It would be an absolute waste of a mind for him to be spending, a year doing, one experiment. It would be a waste. But these guys, they're doing experiments, and I think I listened to a conversation with Mike a few weeks ago, and he said he's got over 150 manuscripts on the go at the moment, all at the same time. 150. I can't even fathom, talking about everything from bioelectricity to consciousness to, multicellular agency and cognition. And it's just, these guys are very busy, and they have to focus themselves, a little bit in one area, which kind of sucks for us. But I think the thing that I'm coming to learn is that they know about all this stuff. See, I didn't think there was so much that I thought Jerry was unaware of, but then a lot of the speakers he invited, I'm like, wow, so you actually know about this stuff. Like, he understands. He had a lot of speakers talking about EMFs and, crazy quantum phenomenon. Even though he sort of pushes back on the quantum story a bit, he gets it. Otherwise, he wouldn't have invited all these people to his conference to talk about it. So that's been a bit eye-opening for me, as I've just trying to mature a little bit more. I realized that when you're a researcher, there are things that you need to be careful with, because you're trying to maintain a reputation, but you're also trying to probably be very careful in the way you talk down at the current regime, I guess you could say.
Sure. I think that's also the argument and the support for what we're doing. It's a decentralizing information and academia, right? It's connecting a lot of these things that they necessarily can't. And I think that's so important to have these conversations. And again, man, like I don't know anybody else that's doing it better than you. Honestly, you're methodical in how you approach it. You do well breaking it sewn and bringing people to get in a good flow. So let's go into a little bit of Medcram, Seheult. Roger Chenault. Go into a little bit of your takeaways from him. How are we applying this? How has he not got canceled? That's something else I would like to know. I told him that the other day. It's like, dude, you keep going down this road, you're going to get canceled. But thank you for what you're doing. So, what did you take away from, that interview and that relationship?
I mean, my first takeaway was how generous Roger is with his time. I think he agreed to see me after a full day at work and, gave me his time. And he had, he was in his little studio, he had the background and he had the microphone and, just how generous these guys are to share this information. He could have so easily just ignored my email. But, he gave me his phone number. He said, oh, just remind me, send me a text. And, these guys are so generous and they're really passionate. And he really cares about working with patients, which I have so much respect for. And I agree with you, like, how has he not been cancelled? He is flirting with danger so much here by talking about what he is. And, there were a few things that we spoke about off recording that, were really interesting about what he's doing, what he's working on. And hopefully there'll be some publications coming from him about, basically taking patients outside and seeing what the results are when, really, really sick patients aren't holed up in a hospital room with no long wavelength light at all. It's basically being irradiated by fluorescent tubes all day. And, from what I've heard from him and others is that, when you take patients outside and, nothing more than that, you just do what you'd normally do, but you take them outside, the transformations are dramatic. And I think this is really where we probably stand to make the most. It's sort of the 80-20. If we can just get people outside, 80% of the problems are solved. And, that sounds so stupid. And there's going to be a lot of pushback, and eventually he's going to have to start saying things like LEDs need to be banned, or we need to really, rethink the lighting situation that we have at the moment. And these are going to be the things that I think get people into hot water, because I can just see the all of the news articles coming out. Oh, there's nothing wrong with LEDs. They're so good for the environment. Yada yada yada. But I think he's brilliant for what he's doing and bringing. He's got over 1 million subscribers, and some of his most popular videos have been ones talking about, red light therapy. And I think he's such a critical, he was on Huberman like last week. To have him in our corner, talking about this stuff is such a massive asset. And I think I need to keep a close relationship with him, because there needs to be more of him on these sort of platforms being asked questions surrounding this. And he's just so generous with his time. How he's managed to get 4 board certifications is crazy. I'd love to see a list of people who have 4 board certifications in America. It's probably diminishingly small.
There can't be many. He's an absolute hero. I mean, he has saved countless lives and gone against the narrative in many ways. And I'm rooting for him. Whatever we can do to help, for sure. So, can you do the elevator pitch to sunlight being that 80-20 solution? Because Cameron, for me, it is so stinking obvious. Now, it did take Jack Kruse in his metaphorical punch in the face for me to get it right. Like he changed my life. I owe everything that I'm doing on now to Dr. Kruse. But give us that elevator pitch for how sunlight is the solution for so much of the chronic disease that we are plagued with.
I think about this a lot because it goes back to that whole thing. If you can't explain it simply, then you don't know it well enough. And I think I would definitely say that I'm in that camp. I don't think I grasp it well enough to explain it simply, but what my elevator pitch would be to someone who has no idea would be to ask them what the biggest changes in our environment have been over the last 100 years. And the reality is, if we are looking at diseases that are from the environment, should we not start at the places in the environment that have changed the most, that are the most foreign? And light is one of, if not the biggest changes we've experienced. And the unfortunate part of that is that our eyes don't pick it up, because we're easily fooled, because we never needed to evolve a way to differentiate between an LED and natural, broad spectrum light. And the elevator pitch really is, if our diseases are environmental, which they are, should our efforts not be focused on the things that have changed in the environment most over the last century? And I think that's as simple as I can get it, because I think that really is just nothing but an appeal to logic. And there's no science in there whatsoever. I'm not, you're not saying light's the whole story. What you're saying is our investigations should begin at the parts of the environment that have changed the most. And I think everyone would agree on that logical sentiment, whether they know anything about light or not. I think that's logical. And I think there are things in medicine right now that we're doing that seem so illogical to me. Like cancer treatment. Let's irradiate you with cancer-causing agents. Where is the logic? I don't quite understand how we've been doing that. And there's been no cancer therapy in the last 30 years that has improved, life expectancy, which is shocking. So that would be my elevator pitch, is not to talk any science, but just to try and appeal to logic.
Yeah, no, I love that. I think that is absolutely wonderful. That's like, hey, let's just compare what's changed the most, when that just happens to coincide with when we're the sickest the most. I
Yep.
I love that, brother. All right. Yeah, another thing I want to get your take on is, how do you package or look at that magnetism piece? So when we're talking about, a lot of what Jack talks about is light water magnetism. Magnetism is maybe the hardest to grasp, but also probably the least talked about, and obviously understood. So how do you do that? How do you package that one for your own understanding?
I think because there's relatively little known about the effects of magnetic fields, particularly the weak magnetic fields of the Earth on biological systems, it's sort of the last one to get spoken about. And I guess it's not like light in that our magnetic field exposure is, drastically different, although it does seem like we are in a swap in the poles of the Earth's magnetic field, which is interesting, because I think if you look at the correlations between mass extinctions and polarity shifts in the Earth's magnetic field, they coincide exactly. So what we do know, there are researchers out there that have looked at things like embryogenesis and how magnetic fields impact things like cell growth or cell differentiation. And magnetic fields seem to be really important, particularly in the growth of embryos. And Wendy Beane, Beane, she was a postdoc under Mike Levin. She's doing fantastic work, again with planaria, but they're looking very closely into why magnetic fields seem to impact biology at that level. And it seems to be mediated by quite substantially by reactive oxygen species. And this is really interesting to me, because anytime you have a charged particle, so reactive oxygen has like an unpaired electron, so it's charged. So in the presence of a magnetic field, it behaves differently depending on the magnetic field. So when you have, let's say, a superoxide molecule in your body, and you're at the equator where the magnetic field is weaker compared to, further up to the poles, fundamentally the reactive oxygen species in your body are going to behave differently. And I think this is something that you lose to some degree if you're living in an apartment building that's off the ground. If you're on the 5th floor, and you're further detached from the Earth's magnetic field, your reactive oxygen species are going to respond differently. They're going to react differently. And we know how important things like nitric oxide are for cell communication. Reactive oxygen species, if you artificially eliminate them or reduce them significantly with antioxidant, you see cancer. Why? Because you effectively breaking down the communication signals. Reactive oxygen species are one of the primary ways mitochondria communicate their state with other mitochondria and how cells communicate with other cells. So when you break that down, you basically impede the cell's ability to communicate, what's going on to all of the other ones. And that's where the classic, Lancet trials using beta carotene had to be stopped early, because when you give people too much antioxidant that's outside of the context of natural food, you increase the risk of cancer. And I think the important thing about magnetic fields is the way that they shape how the cells are communicating. And we know that stronger, like magnetic fields, make easy water. So if you put a magnet next to water, it will generate an EZ. So if you're closer to the pole, that's going to have an effect on all of the water molecules in your body. Even though these are very weak fields, if you're closer to the equator, then the magnetic fields are weaker. So it's, the difference between the water dynamics in those two environments are going to be, I suspect at some point someone's going to be able to pick up differences in them.
So, Cameron, there are two things I want to go on. First, let's tie this back into what you had said about growing a tomato somewhere and shipping it to Siberia, right? Like, because I think that's tied into this, and I think it's even probably more extreme if we're crossing hemispheres. So if you're in a tomato grown in Australia shipped to Switzerland, right? I think that's going to have an opposite nuclear spin. There's a lot of things going on based on that magnetism. So can you tie that in, and then I want to hit on kind of some water definitions in the way that you look at a couple different ones. So I'll do that next.
Yeah, look, I would be purely speculating if I said that the magnetic field, particularly the difference between the north and the south hemispheres, but electrons are not all equal. They all have intrinsic properties that separate them from one another. And, even in the basic textbooks, they say that for instance, the electron that's attached to NADH and FADH are different energy levels. They're not the same. And that's why one goes through complex 1 and one goes through complex 2. And electrons have different intrinsic properties, angular momentum. They have different vibratory states. This was something that Gaetan Chevalier told me, that the electrons that you are interacting with, the electrons in food from one place are going to vibrate at a specific frequency that's specific to that locale. And, I don't know whether those electrons are sort of imprinted at a specific time or whether they change if they're moved. But it might be a reason why we get, I think there are some pretty awesome studies looking at giving cherries to hamsters, which is a bit of an obscure thing to think about doing, but they give, cherries that are grown in season, and they feed them to the hamsters, and they look at their sort of metabolic response. And then when it's, out of season, they'll ship cherries from somewhere else and feed them, and you get a completely different metabolic response. And you think, why is that? They're essentially eating the same food, and a lot of it's probably in response to the fact that the day lengths are different, so their thyroid hormones are going to be, different. The light spectrum, the magnetic fields change not only from, they change throughout the day as well, so you get a stronger magnetic field at night relative to the day. And you think, well, maybe that's changing the way that the body is responding, but who knows, maybe there could be some sort of information encoded in the food that's making the metabolism respond differently. I don't know how or why there would be differences in responses to food like that, but I think it's quite clear. I mean, to me, it's quite logical that would happen. That eating a food grown, in a different continent, shipping it over, and then consuming it, it's going to food is information. It's going to give you information that doesn't yoke with any of the other signals that you're getting.
Right.
And I think we could only assume that that would lead to some sort of imbalance or, infidelity of the signals that are being provided to the body. Did I answer the question? I forgot a little
Yeah,
bit
no,
about what you
you
asked.
did. No, yeah, it did. It just the whole magnetic piece, I think, is a big deal, and I think there's obviously information encoded in food, and I think that's why the ancestrally appropriate diet of local, seasonal, and natural food is the diet. It's not keto, it's not vegan, it's not carnivore. It's local, seasonal, and natural. So, man, there's so many different directions I want to go, Cameron. Um, since we're on that, I'm going to go into a little bit of what we talked about because this is something that I struggle with a little bit on the disconnect of medicinal herbs and things and the food, right? Because this is going to play a factor into the medicinal herbs. So if we're going to take berberine and quercetin and all these things, I think it still needs to be as local to wherever that person is as possible based on this whole thing we just laid out. And I coined, in my Arkansas country boy way, the trying to understand what is going on with these medicinal herbs. The phytophotonics is what I coined it, and it was looking at the absorption spectrums of different compounds, the absorption and the UV range is there in almost all of them, right? Berberine, quercetin, star anise. Like you go into all of the curcumin over and over and over. So the light emission spectrum also right there. So whatever it's doing is something we need to understand better, and it is directly related to light. It has to be, or we wouldn't see these similar things. So what do you think on that in this context?
I think in a perfect world, you're absolutely right, is that the plant compounds, the powerful plant compounds that are used by all cultures for medicine, ideally they are used in the appropriate environment in that, you're using things that are sourced locally, because the things that grow locally are the things that, are going to communicate the right information to your body when they're yoked with everything else. The problem is that today, almost no one has, the perfect signals from their environment. Me sitting here, I certainly am not getting the perfect signals from my environment about where I am. And I think this is where using herbs or plant medicines in general that are not local can be used in a beneficial way by a very skillful practitioner who knows what they're doing. It doesn't surprise me that people, who are living in places where ashwagandha can't grow can get beneficial effects from ashwagandha. And I think that is purely a symptom of the fact that we are so disconnected from our natural environment that sometimes doing things that are not perfectly matching our environment actually can be used in a way to bring us closer, I guess, to a more balanced state. It's kind of like, it's using it as a medicine, and it would be I think you're absolutely right. In a perfect world, you would only use things that are local because they would perfectly match all of the other environmental signals that you're getting. But because all of our signals are so messed up, I think there is a place for using plant medicines that aren't grown locally by someone who, like I said, by someone who knows what they're doing. But finding someone who knows what they're doing is quite a difficult task these days. So generally, I like to just not roll the dice with those kind of things. I don't like to mess around with, berberine or turmeric or things like that. I like to just try and do whatever is locally available at the time. But I think there absolutely is a place for using things like maca or ashwagandha or you name it. There's so many things out there that people can take. But there's a great notion about supplementation that I'll credit to Dr. Anthony Beck. He's the guy that came up with Balance Protocol. Super smart guy. And he says when you're taking anything, you need to consider source, dose, form, frequency, and duration. If you don't consider all of those things when you're taking something, you shouldn't be taking it. You need to know where it's from. Is it high quality? Is it contaminated? Dose, how much are you taking? Form, if you're taking like a mushroom extract, are you taking an alcohol extract, or are you taking the whole form mushroom with the brown rice, or however they do it? And then frequency, are you doing it 2 times a day, morning and night? Are you doing it 3 times a day? And then duration, how long are you going to do this for? You can't just take maca or ashwagandha indefinitely, because you'll mess yourself up. You can't just take turmeric forever, because it's going to mess up your hormones. And I think if you don't outline those 5 things, you really shouldn't be taking anything that's isolated and concentrated. Yeah.
Which also goes back to what you were talking about with Alastair and the hormetic effect, right? Like if we can go too far, right? We can go
exactly.
Too far. So, man, I love it. I freaking love it. All right, something that I have struggled with as I'm trying to write and compile things is water definitions, and having some sort of a terminology that matches, right? So we look at Gilbert Ling or Maywin Ho or Jerry Pollack or Jack Kruse or Barry Nino, where we have different words that I think either that they're diametrically opposed, or they're the same thing called different, right? So easy water, metabolic water, coherent water, deuterium depleted water. Like, how are you able to look at that, and how do you lay that out when we have, some of them do not say the word easy water around them, right? Or that it just sets them off. So how do you view this water conversation in the context of all these different brilliant minds trying to figure things out?
It's a good question, and even at the water conference, there's no sort of standard rhetoric to use surrounding this. Everyone sort of uses their own terminology, which is an unfortunate thing, because I think it allows a lot of research to go unnoticed because they might be using different terms. I know Jack likes Del Guidice's ideas about coherent domains, and I've been reading a lot more about Emilio's work. And he, particularly his work with Jacques Benveniste and Luc Montagnier, and basically how homeopathy can work, in that these water structures form that are capable of capturing electromagnetic energy and storing it in the water matrix itself. And that was the idea of a coherent domain, sort of this structured part of water that was capable of capturing and holding energy from the environment, and these coherent domains would form when an experienced homeopathic doctor would shake the vials. They know how to generate these coherent domains, and that way, even after repeated dilutions, what happens is the energy that's stored in the structure of water basically takes up the whole vial, even though there's no original compound left. The energy, the electromagnetic energy from those compounds, are stored in the water. And that's the basic idea of coherent domains and how it applies to homeopathy. What I learned at the water conference was that Luc Montagnier's experiment, a very controversial experiment where they could recapitulate DNA in a tube from Italy to France just by using a wave file, an audio file. This has been repeated 6 times by 6 different independent laboratories around the world. So there's definitely something to this idea of coherent domains, and I think Jerry's idea of EZ is actually exactly the same thing. What he's talking about is this type of structured water, except Jerry lays it out as sort of just this charge separation event, which I think is very helpful to get people to understand what's going on. But I think within those lattice structures, there's more going on rather than just a charge separation. That's what it sounds like. And then I wish I could remember her name, Romina something. She presented. She has done work on aquaphotomics. And what she's doing is basically getting different types of water and exposing them to different wavelengths of light and seeing what the absorption spectra is. And she's been doing great work just showing that water has all of these different structures because she can show all of these different absorption spectra of different waters. And the only way you can get different absorption spectra is if you have different structural components of the water. And if you can check out her work, it's quite brilliant. I'm surprised I hadn't heard of her up until that point. But hers is probably, if you want to show someone that water has different structural elements, her work is the best because it's so straightforward. You use light to identify that there are different wavelengths are absorbing in different types of water. There must be different structures in different waters after different preparations and different treatments. I think I like to lean more towards using the term structured water or water with structure, just because I'm not giving my allegiance to anyone in particular.
Yeah.
What we do know is that there's some sort of structure. What that is, I'm not sure, but structure. The water has some sort of coherent structure to it.
Well, and I think that this is the area that I was trying to tie in earlier with Barry, right? Like, we got to talk about nanobubbles in this, right? Like that is a variable, and probably a very, very important, if not the most important variable, right? So and who knows, right? Maybe it's not, but that just really makes it a little challenging, and I think it's a big deal, and we don't have the answers that, at least I would like. You said something else. There's so many different directions, man. I love it. I love the conversation. It just ties together.
Well, I will say that I think Jerry's ideas and Barry Ninham's ideas actually are quite cohesive, because Jerry has talked about bubbles being nucleating sites for structured water or easy water. So I actually see their work gelling together quite well. I don't see that, I think they can coexist quite harmoniously. That being said,
what you just hit on, man, is why these type podcasts are so important, because I see the similarities in different people's talks more than I see the opposition, and I think that that's where the magic comes.
Yep.
Two things I want to ask you about. Recently had Mario with Analema Wands on, and a guy that talked about Vogel crystals and trying to just understand that, right? And I'll be honest, I don't understand the Analema thing at all. But I've had one for probably 3 years now, and there is not been one person that we have done a blind taste test that didn't tell the difference in the water and didn't prefer the one that had the Analema used. You got any thoughts on that?
Yes, everyone I know who has an Analema has said the same thing to me. I don't know what to make of it because I don't understand it. If I had to guess, I would say that the reason it's having this effect is, if I had to guess. So Veda Austin's work. She's awesome, and she has shown very, very reliably that even doing something like holding water up to your heart for 10 seconds and then freezing it completely changes the crystal structure. And what I think these things like Analema wands are doing is actually being a device to draw our attention and intentions towards the water. And it may be that the wand itself is not doing anything, but what it's doing is it's triggering you to actually focus your attention on the water and put some sort of positive intentions into it. So it may be that the wand is not, there's nothing intrinsically special about the wand, but what it gets your consciousness to do, and how it brings your attention to the water. Because most people, they pour a glass of water, they drink it. They don't think about, the water at all. But what you're doing when you're using an Analema is actually bringing your intentions directly to the water in a way that you wouldn't otherwise do. And I have no idea whether that's true or not, but I think just because we have difficulty explaining what it could be doing, The word quantum gets thrown around a lot when
Sure.
we're talking about this stuff. And I have no doubt, I've never tried water that's used in analema, but what I use at the moment is I just have an empty wine bottle, and I just fill it up, and I spin it and vortex it into my into my cup. And same sort of thing with the analema. It's night and day between the unvortexed water and the vortexed water. The mouthfeel is so different. But we don't really know what's going on with this analema stuff. But there were a few people at the conference talking about it, and it does seem to have some difference, have some impact on the structure of the water and the properties of the water, which I was surprised to hear. But there was some data shown using the analema, so I don't know what to make of it. They're very expensive and they break a lot, is what I know. But
I've broken four.
yeah, if all you really need is intention, then I don't know. There's no shortage of gadgets out there, but I don't know how they work.
Yeah, and that's the whole thing that's just completely turned me off about the biohacking world. I think that it's a bunch of crap that people are trying to charge money
Yeah.
for instead of just like getting back to nature and embracing what we've laid out in this entire conversation. One thing that come to mind when you were talking about that Veda Austin's work with holding it to your heart, I wonder how much of that has to do with magnetism, right? Like the magnetic, we know we can pick up heart for like what 21 feet away or something. So it's just something that came to mind. Um, Cameron, on the analema stuff, they also have this whole house thing. This is only where that it's just to play devil's advocate here. There's no intention there, and it's still having some sort of a benefit. So it's like, you know what I mean? Like it just goes in line, and then they're having all these same type of effects, whether it's a bath or whether it's drinking water, or whatever, and there's no intention. So I think that's also very interesting. And then to wrap in on this vortexing and then the Vogel crystals, like I don't understand that either. I have no idea what this even means. But the quartz, we know this from Gerwich. There's something with water and light and crystals. Like what do you got?
Well, it's interesting. At the water conference, I was spending a bit of time with Sarah Pugh, who, had her Vogel crystal. She was stirring her water with the Vogel crystal. I don't know anything about Vogel crystals, but it doesn't surprise me at all that these types of things impact water. There's really nothing that doesn't impact water. It seems, and Veda always talks about water being alive, and the more I hear, the more I think, yeah, it really is responding. It really is like an active participant somehow, and we don't understand how. And yeah, so Vogel crystals, and you mentioned something else. What was the other thing?
Just kind of the heart magnetic field having maybe an effect on the water.
Almost certainly that would be having some sort of effect, but how it's potentiated, because you would think if you hold it to your heart, then it's having an effect. But as soon as you remove it from the influence, you would think, logically you'd think, well, that effect's going to go away. But it seems to be able to imprint. Yeah, I heard a lot of people talking about imprinting. There seems to be this phenomenon with water to the point. I'll give you a very jaw-dropping thing. One of the most jaw-dropping things. Robert Haralick, who runs a very well-funded, he's a very successful computer scientist, and he's doing water research now, and he spoke about the beakers that he uses in his lab. And he says once you use a beaker with water once, you have to throw the beaker away because the water imprints on the beaker, and when you use it for a new experiment, it influences the previous water that was in there, influences the new experiment. And he didn't show any evidence for that, but he says, in our lab, we know beakers have to be, they, because of this imprinting thing, there seems to be something going on there. That was, and he just said it like it was nothing, and then kept talking with his presentation, and my jaw hit the floor when he said that. But Yeah, I mean, there's a lot of stuff going on with water that we don't understand. That's for sure.
It's just fascinating. It's like the other thing that just it hits me over and over and over. It's like every layer of this onion that you get deeper in, and you think, man, we got it, we understand. It's like, no, you don't. No,
Yeah.
you don't. It's more complex. But with on the same token, the solutions are pretty dang simple too, right? Like, so let's go into that as we wrap this up, brother. Let's go into some of the solutions and the way that you can support these super basic get with nature, eat local, seasonal. You can support it with the science, but what kind of solutions do you kind of make sure that you let friends, family, and those that follow you lead them to follow?
I mean, it's hard to move past just getting outside, because generally when you're outside, you're moving. Hopefully, you're not wearing sunglasses, and whether you're in the sun or directly or not, it's kind of when I'm trying to get people to understand this, it's sort of a moot point whether they have their clothes off or not, whether they got their skin in the game or not. Just getting outside, again, it's this 80-20 principle. You solve so many problems just by opening the door, even opening a window, to let some natural light in. And the reality is that solves so many problems as well. So you get so many things for free if you just do that. So if you do that a lot, your sleep is going to be better, for instance, and everyone knows how important sleep is. If you do that, your hunger, your appetite is going to be more well regulated. So you're going to eat at a frequency that suits your energetic needs. And when you're outside, your mitochondria are capable of making water much more efficiently, because that electron can meet oxygen more efficiently in the presence of sunlight, to make water. So you're more hydrated when you're outside, even if you're not in direct sunlight. So you get a lot of things for free when you just do that. And I think that's what makes outdoors such a beneficial thing. You talk about vitamin N, nature, and forest bathing, why they have such notable beneficial effects. It's not because you're getting one thing. It's because that one thing is at the core of your physiology, and if you can address that, everything downstream from there is benefited from that as well. So depending on who I'm working with, that's really one of the big ones. But another one, I had, just as a sidetrack, I had a client that I worked with a few months ago, and he was doing everything right. Like, he was doing things way better than me. He was, swimming in natural bodies of water every day. He was outside all the time. He was, exercising. He was eating like hyper local. Like, everything he was eating was grown like in his town. Local seafood. You name it. He was doing everything right. Circuit breaker in the house. Like, barely had any exposure to, electromagnetic fields. And he just wasn't thriving. And I found out that he was living quite far away from his friends, and he didn't see them very often. And like, I said to him, like, honestly, you're doing things so well. What you're missing is this social dimension of your health. You need to go to a friend's house, have a cards night, watch a comedy show, and just laugh and be with people, and give them all hugs. And I think this is something that a lot of people in the health space are neglecting. It's sort of this dimension of health that is forgotten about. And I've been writing an article about that the last few days, and just doing the research on the impact of laughter on all-cause mortality is amazing. Like, people who laugh more live longest. I mean, it's just as simple as that. People who have the most physical touch live longer. they have more resistance to disease, all sorts of diseases. People who play, you have to play. It's not an option. It's at the base of Maslow's hierarchy of needs. You have to play. Kids who don't play enough are significantly more likely to commit crimes, particularly heinous crimes like murder. And we've sort of forgotten that this dimension of health is so important. And we need to hug, we need to dance with people, we need to do all of these things. They're just as important as the food we eat. They're just as important as the sunlight. And you go back to work with rats. I think it was Jaak Panksepp who found out that if you take rat pups away from their mothers, it doesn't matter how much nutrition you give them, how great their environment is, like how intellectually nourishing it is. If they get no touch, they just die. And you can alleviate that by just rubbing their bellies with the eraser end of a pencil. And that was enough touch for them to live. But if you didn't do that, they would just die. And there was work by Harry Harlow back in the late 50s where they had, they took rhesus monkeys, babies away from their mothers, and they basically gave them two options. They gave them like a wire, like surrogate mother. It was just like chicken wire, but it gave them milk. Or it gave them like a plush doll of like a monkey that provided nothing. And the monkeys constantly they went without nutrition to hug the cuddly version of the mother that they were so longed for. And I think, in studies like this, although they're highly unethical and they'd never get done today, show us that, it's arguable from that point of view that, this aspect, the touch, the love, the play, it's more important than nourishment from food. And I think the fact that we have all of these different models, the fact that we have play circuits in our brains, and so do rats, and so do dolphins play, and dogs and cats all play, and wolves play. It's such an important part of health that we just don't take seriously enough. And this guy, I only saw him once because I'm like, you don't need me. Like, you don't need anyone to tell you what to do. You're doing it super well. And he emailed me like a month later saying, dude, you're right. I'm doing so much better, spending more time with people. I actually encourage people to sit down and watch comedy shows that they find funny with friends, because I think that's, at times it's more important than, getting the light from the TV or whatever. So this is really a forgotten aspect of health that I'm quite passionate about, and not many people are talking about it in the health space.
Dude,
so
I think you are spot on. I got chills, brother. That's perfect, man. That's a mic drop moment, my friend. Cameron, thank you. You're spot on, brother. Dude, thank you for the time. Thank you for the work you're doing. You got a ally right here in me. Anything I can do to help, my friend. Always here.
No, it means a lot to have the opportunity to speak with you. I really appreciate it, and it's just great to have such wonderful people in this community to bounce ideas off and just be collaborators with in this sense. So I appreciate it very, very deeply, and thanks for having me on.